All right, hi everyone. In this video, we are going to talk about how we can create and store matrices in R. And so the main function for creating a matrix in R is the matrix function. So I define my matrix function and then I input some arguments inside of that function to create my matrix. And so the arguments that we mainly need to specify are, first of all, what are the values that I want to arrange in a matrix? So in this case, in this first code cell down here, we're going to arrange when I use 1:10, that means that's a vector of values from integers 1, 2, 3, 4, 5 up to 10. So this is telling me we're going to take the first 10 integers. Those are going to be the elements of my matrix. So my matrix is going to have all of the integers from 1 up to and including 10. And then I indicate the dimensions of the matrix. I specify the number of rows and the number of columns using n row and n column. So here I've got 10 values from 1 up to 10 that I'm going to store in a matrix that has 5 rows and 2 columns. So I'm going to create a 5 by 2 matrix. We would call that a 5 by 2 matrix. So I'm going to run this code cell, and this is also going to output, it's going to print matrix A to the screen. So what I can see here is in the output, it's telling me what data structure A is. A is a matrix. It's telling me that it has 5 rows and 2 columns. I can see that in the output as well. And it's telling me that each element in my matrix is being stored as an integer. So all of these values are integers. So I can see all of that information from up top, and then down below, I can actually see the matrix itself. And if we were writing out this matrix ourselves by hand, then it would look like, as we're showing over here in red, we typically write these matrices inside of a set of square brackets, or maybe we'll use rounded parentheses. But this would be this exact 5 by 2 matrix that we created with this code cell above. So it took these 10 values, these 10 integers, 1 through 10, and arranged them in 5 rows and 2 columns. And just notice that, first of all, it arranges things. The first 5 values went down the first column, and then the next 5 values went down the second column. And if we go ahead and do print A to see what it looks like when we print it to the screen with the print command, it looks a little bit different than what we had up top. So when we printed A out just by typing A, it includes information about what data structure it is, what the dimensions are, and what data type the elements of matrix A are. When I use the print command, notice we get similar looking output that looks a little bit different. And so what I'm looking at over here is it's telling me the row index for each of these rows. And up top, this is telling me the column index. So this is indicating column 2. This is indicating column 1. This is row 1, row 2, and so on. So it's the same matrix with the same values. It just gets displayed a little bit differently depending on whether we just type A or whether we type print A. Either way is a reasonable way of displaying the matrix on screen. And these arguments, n row and n column, that's great. We can specify we want these 10 values arranged in 5 rows and 2 columns. But notice, if I don't need to enter both of these things. So if I have 10 values that I want to arrange in 5 rows, well, then by default, there's going to be 2 columns. So in fact, I could have coded this up a little bit differently. And if instead of indicating both the rows and the number of columns, let's say I just indicated the number of rows, then it's going to create the same exact matrix because it knows if you've got these 10 values and you want to organize them into 5 rows, then each row is going to have 2 columns. And vice versa, if instead I only indicated the number of columns to be 2, well, then it's going to realize that you've got 10 values that you're going to arrange into 2 columns. Then each column is going to have 5 rows. So either way that I would have done this, giving both the number of rows and the number of columns, or just indicating the number of rows, or just indicating the number of columns, we're going to get the same output in the end anyway. So all of these gave us the same output. If I don't indicate any number for the number of rows or for the number of columns, then I'll just say, let me call this something else. I'll call this B so I don't define a new matrix. Then what I would get here is something different. So this assumes that I just wanted one column of value. So this actually creates a column vector, a vector that has 10 rows and 1 column, which is different. So I do need to specify either the number of columns or the number of rows, or we can indicate both to be very precise about it. And one last thing to mention here is that when we set up this matrix, notice that the way this was set up is it took the first 5 values and that's what it made the first column. And then the second 5 values were the first 5 values were column 1. The second 5 values were column 2. There is an argument that I can add, which is the by row argument. And this is going to tell R that rather than arrange the values first down the first column, then down the second column, and so on, this is going to create a matrix that has of integers 1 through 6. We're going to set it up into 2 rows and into 3 columns. And if I use this by row equals true argument, then what that means, it's going to take these 6 values and it's first going to arrange them across the first row. So it's going to say, okay, I want a matrix that has 2 rows, 1, 2, and 3 columns, 1, 2, 3. So first start by arranging these values across row 1. So it would give me 1, 2, 3 across the first row, and then it's going to fill up the next row with 4, 5, and 6. So if I run this code cell below, I should get this matrix that I just drew in red above, and I do. If I take this code and remove this argument, then the default is that it's going to fill down the column. So if I don't put a by row argument, it's going to use the default, which is by row is false. And so it's going to arrange them first down the first column, then down the second column, and then finally the last 2 values would be down column 3. So I get a matrix that has the same dimensions, just the values are laid out in the matrix in a different order. So if I run this, we'll kind of double check that we get the output over here. And we do. So there is a difference. It doesn't change the dimensions, the rows and columns, but it changes the order in how we assign elements to different positions in the matrix. So if you don't indicate anything, the default is it's going to arrange it first down column 1, then down column 2, then down column 3. And we'll see that there are going to be plenty of times where we might want to do it differently, and we might want to first set up the row, then set up the second row, and so on. Okay, so we'll stop here and give you a chance to practice this in the next video. Thanks.